In the previous videos, we have completed with the exercise 6.1, and in this video, we are going to start with the exercise 6.2. So, welcome back, and let's start the exercise 6.2. Firstly, before doing examples of 6.2, we'll be doing some introduction concepts. For example, the first concept which will be used in this exercise is of parallel lines and a transversal. Parallel lines, of course, the lines which do not meet, and they meet at infinity. It is said that parallel lines meet at infinity. It means they literally do not meet, so those lines are known as parallel lines. And what's a transversal? A transversal is a line segment that is intersecting two parallel lines. Not a line which is intersecting any two lines, only two parallel lines. That line will be known as a transversal. Now, I have drawn the diagram already for your convenience, and there are two parallel lines. First is AB and second one is CD. And which one is the transversal? Guess, that is MN. Okay, so we will be doing some of the properties of transversal and parallel lines along with some of the angles, that what kind of angles are formed when a transversal intersect two parallel lines. So I have named the angles like A, B, C, D, E, F, G, H, and we will be defining some of the angles along with the names that I have already given in the diagram. So firstly, we will study what corresponding angles are. Actually, it's a lower class concept, so you should be reminded of this very easily with this video. Corresponding angles. Which angles are corresponding angles? You have to remember the position of corresponding angles. Corresponding angles are A and E, B and F, C and G, D and H. So if we name the pair of corresponding angles in this diagram, that will be angle A and angle E, and the next one will be angle B and angle F. The third pair will be angle C and angle G. The fourth pair will be angle D and angle H. Alright. Our next kind of angle is alternate interior angles. Alternate interior angles. Now there are two kind of alternate angles, which is very vivid from the first type, that is alternate interior angles. So there will be alternate exterior angles as well. So which are alternate interior angles? Alternate interior angles are angle C and angle F, and angle D and angle E. So the pairs will be angle C and angle F. The other pair will be angle D and angle E. You can say that this is kind of if a Z is being formed, and the both angles at the corners are alternate interior angles. Now similarly, we'll be studying alternate exterior angles. Now it is easy for you to guess that which angles are alternate exterior angle. So I would really recommend you to pause the video over here and just find the alternate exterior angles in a similar way in that I have found the alternate interior angles. So if you are unable to find the alternate exterior angles, let me help you. And the alternate exterior angles are A and H, B and G. So pairs will be angle A and angle H. The second pair will be angle B and angle G. Alternate exterior angles are also done. The last one remaining is interior angles on the same side of the transversal. Now this kind of angle is defining itself very easily. What are interior angles on the same side of the transversal? This is transversal, and on one side there are interior angles which are interior C and E, and they are on the same side of the transversal. So interior angles on the same side of transversal, if we want to form the pairs, so the pairs will be angle C and angle E, and the second pair will be angle D and angle DFCE. So you have to remember the position of all of these angles. Now we have defined all of the angles that are going to be used in the concept of parallel lines and transversal, and there will be axiom and theorem based on each and every kind. Some axioms proof is given in your book and some axioms proof is not given, so we'll be doing only that are in your syllabus. So just be ready to do the axioms 6.3, 6.4 and the theorem 6.2 and the following axioms related to all of this. Let's start with the axioms 6.3 and 6.4, which I have already written for your ease. So axiom 6.3 states that if a transversal intersects two parallel lines, then each pair of corresponding angles is equal. If a transversal is intersecting two parallel lines, then the corresponding angles thus formed are equal. And the next axiom is the converse of this, that if a transversal is intersecting two lines such that the pair of corresponding angles is equal, then the two lines are parallel. So let me just make you understand with the help of a diagram, and there is no proof of these axiom, though axiom 6.4 is proven a bit in your book, but it's not the proof of axiom 6.4. So let me explain it just with the help of diagram, and you will be able to understand. These two axioms are known as corresponding angle axioms, and these are very very important in order to attempt the sums which you are going to face in the exercise as well as the examples and other theorems as well. So just understand these carefully. Now, if a transversal intersects two parallel lines, let's draw two parallel lines and a transversal obviously, which is intersecting these parallel lines, then each pair of corresponding angles is equal. Firstly, name the parallel lines and the transversal. So the parallel lines would be ABCD and the transversal can be MN. Then each pair of corresponding angles is equal. Now we have studied that corresponding angles are the angles for let the point of intersection be E and F. Okay, so what are the corresponding angles? Corresponding angles will be MEA EFC, then MEB and EFD. These are the corresponding angles. So if it is given that transversal intersecting two parallel lines, only parallel lines, then it is automatically understood that the corresponding angles are equal. So according to axiom 6.3, the angles which are angle MEA will be equal to angle EFC, and the another pair, that is angle MEB, will be automatically equal to angle EFD. So this is what axiom 6.3 is stating. Now axiom 6.4 is completely converse. It's saying that a transversal is intersecting two lines. Now it's not given that the two lines are parallel, but it is given that the corresponding angles are equal. It means this condition is given, so it's automatically defined that the two lines which the transversal is intersecting are parallel lines. So this is the converse of axiom 6.3, and these two angles are known as the corresponding angle axioms. Okay, so just make these axioms very much clear in your mind in order to attempt the further theorems as well as the other examples and sums. So this is what actually axiom 6.3 and 6.4 is trying to say. If the corresponding angles are given equal, then the lines are parallel, and if the lines are parallel, it's given that lines are parallel, then the corresponding angles are equal. As simple as that. Let's start with the theorem 6.2 and read the statement. It states that if a transversal intersects two parallel lines, then each pair of alternate interior angles is equal. Now a transversal is intersecting two parallel lines. So let's draw two parallel lines. It's already given that the lines are parallel, so don't worry. Let's draw two parallel lines, AB, CD. Transversal is intersecting them, so draw the transversal. Our transversal can be MN and the points of intersection can be O and P. So this is the diagram that is being stated in the first sentence. Then each pair of alternate interior angles is equal. Now what we have to prove? We have to prove now which are alternate interior angles. Now alternate interior angles are angle AOP and angle OPD. angle AOP is equals to angle OPD, or of course the another pair, angle BOP is equals to angle OPC. Angle BOP is equals to angle OPC. Now in your book the proof of this theorem is given, but it's actually the proof of its converse, so stay tuned with the video to know about its exact proof, and it's very much easy, so you don't have to worry about any kind of complications that you can face. So firstly, you have to write each and everything that is being constructed by you, that AB and CD are two parallel lines, and consider MN is the transversal of these two parallel lines, and suppose that it is intersecting the parallel lines at the points OP. Okay, you have to write the construction points, that the diagram that you have drawn. So now firstly we'll start with the things that we are knowing already. So firstly we have to prove that angle AOP is equals to angle OPD. Now it's given that the lines are parallel. Clear? Now the lines are parallel, so we have studied the axiom 6.3 and 6.4, that if the lines are parallel then the corresponding angles are equal. So which are corresponding angles? MOA and OPC. Since the lines are parallel, then angle MOA will be equal to angle OPC. Why? Because of corresponding angle axiom 6.3. You have to mention the reasons of each and every step that you do in geometry especially. So MOA is equals to OPC. Clear? Also MOA is equals to BOP. Also MOA is equals to OPC. Now why? MOA is equals to BOP. I'm sorry. BOP. MOA and BOP are vertically opposite angles. Just tilt your diagram a little bit and you will get to know that MOA and BOP are vertically opposite angles. Clear? Now from equation 1 and 2, from equation 1 and 2, it is clear that OPC, if left hand sides are equal then right hand sides are also equal. So therefore angle OPC is equals to angle BOP. It means OPC and BOP were which angles? The alternate interior angles. So one pair of alternate interior angles is equal. So similarly you can prove AOP is equals to OPD, because in that way you will take MOB and OPD as your corresponding angles, and then MOB will be equal to AOP, the vertically opposite angles, and then ultimately AOP will be equal to OPD. So in this way you can prove the second part as well. This is what 6.2 theorems proof looks like. Now it's very easy that you have seen that we have proved the whole theorem in only 2 steps. You should be knowing the axiom 6.3 and 6.4, as I have told you previously as well, that these are very, very important. Our next theorem is theorem 6.3, which is an exact converse of theorem 6.2. In 6.2, we have dealt with the concept that if two lines are being intersected by a transversal, then the alternate angles so formed will be equal. So the converse will be, you are very intelligent, so guess the converse. What will be the converse? Okay, let me help you. If a transversal is intersecting two lines, now a transversal is intersecting two lines and it's not at all given that the lines are parallel or not, and the pair of alternate interior angles is equal, then the two lines are parallel. It's proven. It's basically like axiom 6.4, 6.3, that was the converse of corresponding angles axiom. So just keep this in mind. If the alternate interior angles are equal given, then the two lines are parallel. Theorem 6.4 and 6.5 are also the converse of each other. They are saying that if a transversal is intersecting two parallel lines, then each pair of interior angles on the same side of the transversal, it means AFG and FGH, the sum will be 180 because supplementary, and theorem 6.5 is the exact converse of 6.4, that if sum of these two angles is 180 degree, then the lines will be parallel. So these were the theorems and axioms that will be used in this exercise. So keep keep these in mind before attempting sums. If you want proof of any theorem in personal, you can use the comment section. So before leaving, do like, share and subscribe my video.